Okay, so here's the second example that we didn't get to in class on day 1 of ellipses. So here's my equation. I know it's an ellipse equation for a couple of reasons. First of all, it has the look of kind of like a circle equation with the x squared and the y squared and the equals, but when the denominators are different, that's going to make it an ellipse, and we always set it equal to 1. So if it wasn't equal to 1, we would divide everything through and that's how we end up with those fractions. So with that, we can decide, we need to find a, b, and c. So remember that the denominators determine this. One of them is a squared, one of them is b squared. A is always bigger than b, so a is always bigger than b, which is always bigger than 0, because if it was 0, it would be undefined and it wouldn't work. So that means that this is b squared, and this is a squared. All right? So since that is the case, a is 6, b is 3, and because a is under y, that means the orientation is going to be vertical instead of horizontal. I'm going to need c for what I do, so I know that c squared is equal to a squared minus b squared. I mean, I could take these and square them, but I also already know what a squared and b squared are, so c squared is equal to 36 minus 9, which means that c squared equals 27. So c is 3 times the square root of 3, because it's the square root of 27, and when you simplify it, that's what you get. As a decimal, because we have to have, some idea of what to graph when we're there, this would be 5.196. And you should have a concept that it's a little bit more than 5, because 27 is a little bit more than 25, but we want to have a little bit better than just a concept. I don't expect you to come up with that number from your head, but knowing that it's a little bit more than 5, yes, we should be able to reason through that, I would hope. Okay, so now to find our center is still just HK, so this is going to be 3, negative 1. Okay, and then I'm going to circle mine, because like I said in class, I know to use the center, but I was coming and grabbing these points on some of them, and it's easy on anything to just use the wrong number, so we just want to be careful with that. All right, so some things I need to be able to graph here. I need my vertices. So since this has a vertical orientation, my vertices are always on my major axis, and my major axis is going to be vertical, so that means that that's going to change my y values, okay, of my center. So my center, let's just go ahead and graph that. My center is at 3, negative 1. So I go to 3, negative 1. This is my center. So my vertices are going to be along somewhere on that vertical line of x equals 3. So I know that up here on these, my x value is 3 for both of them. Then the y value for the center, I add and I subtract a. And my a value is 6. So negative 1 plus 6 is 5, and negative 1 minus 6 is negative 7. So those points then can plot 3, 5, and 3, negative 7. So 3, 2, 4, 5, that's a vertex, and 3, negative 7, that's another vertex right there. So then my co-vertices are going to go along the vertical line y equals negative 1. So for the co-vertices, the y value remains the same, which is negative 1 for my center. And then the x value of my co-vertices is the h value of the center point plus or minus b. So if I take 3 and add 3, that gives me 6. If I take 3 and subtract 3, I get 0. So my 2 points are 6, negative 1, and 0, negative 1. So 6, negative 1 for a co-vertex, and 0, negative 1 for another co-vertex. All right. Then I go back up here. Let's see what else I need. So I need my focus point. That's why I needed that C. So the focus is also along the major axis, and the major axis is my vertical, is going to be vertical. Okay, so we're going along that Y there, which means your X stays the same. So the x for the focus, both focus points, is the same as the x value for the center and for the vertices, because they're all along that same line. So it's 3 and 3. And then your y values for the focus are the y value, or the k, from the center, and you add the c value, and then you also subtract the c value. So I'll have -1 plus 3 square root of 3, and -1 minus 3 square root of 3. So to have a decimal approximation in my mind when I go to graph, since this is 5.196, basically, if I take -1 and add that, that's going to give me a positive 4.196. If I take -1 and I subtract that, that'll give me a negative 6.196. So then my major axis, which I know is vertical, to find that value, it's very simple. It's just 2 times A. A is 6, so this is 12. Minor axis is 2 times B, so that is 6. The length of the focal chord, the way I find that is 2B squared over A. And so that's going to give me 2 times B squared, which is 3 squared over 6. So that's 9 times 2. So 9 times 2 is 18. Divided by 6 is 3. So I can plot another point here. Oh, I need to plot my foci first for focus. So I've got 3 and then 4.196. So I go to 3 and then 1, 2, 3, 4 and a little bit, and that's focus. And then 3 and negative, is it negative 6.196? So 3 and then negative 6.196, about right there, which will be a focus. Then I can graph from there my focal chord length. If the focal chord length, remember the focal chord is going to be here, comes parallel to the axis. And I can, since the length is 3, I'm going to go 1.5 out on each side. So it's still kind of eyeballing like 1.5. That would be a point on my ellipse. And about right there, that'll help me with my, it actually might hinder, it might make me make it a little bit more pointy. And you don't have to plot this point. I just want you to see why we would even care to be able to let it help us with our graph. There's just 2 other points. We're not going to label them with anything, but we use the endpoints of we use the length of it to find those 2 points there. All right, then back up here, the eccentricity, which isn't anything you graph, just something I thought would be good for you to know exists. E equals C over A. So that means that this is going to give me C, which is 3 square root of 3, over A, which is 6. And so that reduces to the square root of 3 over 2. And then that's come up a lot with radians and stuff. So, there's some square root numbers that you should start kind of being familiar with what the decimal approximation is. Definitely not a memorization thing, just a recognizing it type of thing. So it's easier for you along the way. All right, so since I have all of that, I can come back over here and I'm going to sketch in my ellipse, which mine is kind of big, so the chances of me actually getting this decent is like slim to none, but if it was on a smaller piece of paper, it might be better. You see how it helped me go through that point? And this is when I wish I had the wooden board, my Cody board, and some string. That isn't half bad. There is my ellipse. Now, if you look at that and you compare that to the example 1 that we did in class, my board will go. Okay, so this one, that was more like a football, but this one was maybe a little rounder, a little more circular than the one we just did. This one is a little bit more squished looking, and I would know that without even graphing it based on the eccentricity. The eccentricity from example 1 was 0.745, and this one's about 0.83 or 0.866. So that makes it a little bit more stretched out, because remember, the closer you get to 0, the closer it is to a circle. So there are all those pieces. We could find it by just, graphing and knowing which, that this right here is B and so forth. So let's label some of that. I think that might be helpful. So this length right here, this length, remember, is B. This length here is A. Oh, shoot, my little arrow didn't go far enough. All the way down there. That is A. Because the length just to here, to the focus, this right here is the C, which is different. That represents center, but that would be my C length. Okay, so there are those things. And then your focal chord is right here, and the length of that would be 3. Right? That helps us get our shape of our ellipse. And there you go.